Good morning, students. I hope all are safe and fine in your home. So due to this pandemic situation, we are conducting class through online. So my subject is Optical Communication and the subject code is EC8751. So here I have given you the subject syllabus for your reference. So go through it and note it down. Okay. So coming to the subject, what is optical communication? We know communication means sending information from one place to another through the medium. Correct? Okay. So previously we have studied the analog communication, digital communication. So here we are going to study the optical communication. That is, shortly we can say the optical communication is the communication through light. Okay, so here there are some textbook and reference book. So go through it. So first we can move to the introduction of optical fiber. So coming to the introduction of optical fiber, you know about the optical cable, that is, it is in the pipe shaped. Okay, so through this cable only, the light is carrying from one place to another place. So students, have you ever think how we are getting the message in a fraction of seconds through the messages or through the internet or through WhatsApp, any medias? So through this optical fiber cable only, because you know light travels more faster. Okay, so here see the optical fiber cable. Inside the pipe-like structure there are many thin wires. Okay, so these wires are so much of thin as of our hair. So through this cable only, the light is transmitting from one place to another place. Okay, if there is no optical fiber cable, and then there is no internet access. So students, we can study detailed about the structure of the optical fiber cable in the future classes. Okay. Next thing is the optical spectrum. It is, you know, the light is the kind of the electromagnetic spectrum, and the spectrum range is between 3 into 10 power 11 to 3 into 10 power 16 Hz. So this includes the infrared spectrum, ultraviolet spectrum and visible light spectrum. Okay. So you know infrared spectrum, the frequency of the infrared spectrum is very high. That is, we can't see by the human eye. So for example, if you take some laser light, it can't seen by the human eye. So next is the visible light spectrum. So this band is visible to our human eye. So the range is between 390 nanometer to 770 nanometer. So between this visible light, the lights are possible to seen with the human eye. And the next one is the ultraviolet spectrum. This band of light is there is too much of low. Okay, and it also visible by our human eye. Coming to the advantages of the fiber optic cable. First one is the important advantage is the wider bandwidth. So if you see the fiber optic cable, the bandwidth it can carry about 11 terahertz. Okay, while coming to the copper cable, it carry only about the megahertz. Okay, so the information carrying capability of fiber optic cable is very high. The next advantage is the loss is very low. We are preferring the fiber optic cable mainly because of this low loss. We can transmit the information over the long distances. Okay, and next is the lightweight. So here the cable is made up of either glass or plastic. So the weight of the cable is very low. Okay, and next is the security purpose. It is the main advantage. So it is a non-conductivity medium. So the security is very high. It can carry the information very fast and easier, and no corrosion. Okay, if you are using the copper cable means definitely there will be a corrosion, and there is some electromagnetic interference also there. If you are keeping a mobile nearby the TV, definitely there will be a vibration. Why? Due to this electromagnetic interference. The next advantage is we are using the repeaters. Okay, why we are using this repeaters? We can transmit the signal with the maximum data rate. Okay, so while we are studying the elements, you will understand about this. Next is the environmental immunity. That is, it is a very resistive layer. The optical fiber cable is the very resistive layer, and it can operate over the wide temperature range also. Okay, already I said that it has no corrosion. Okay, and next last advantage is the low cost. The cost of the fiber optic cable is very low. Students, the next important topic in this unit is, up to now we have seen the introduction part. So this is the element of an optical fiber transmission link. It may be asked in the 13 mark question also. Okay. So the basic component of the optical fiber communication are the transmitter section, the medium that is the optical fiber, and the receiving section. Okay. So we know for communicating the three main important elements are transmitter, medium, and the receiver section. Okay. So we can see one by one. So first, the input signal is the electrical signal. So listen, students, listen here. So here all the dashed lines are the electrical signals and the zebra lines are the optical signal. See the diagram, all the dashed lines are the electrical signal and all the zebra lines are the optical signal. Okay. So first, in the transmitter section, what is the purpose of this transmitter section? In the diagram itself, we can say that the electrical signal is converted to the optical signal. So here, the electrical signal is converted to the optical signal. So the dashed line is the electrical signal and the zebra line is the optical signal. So first, how this electrical signal is converted to the optical signal? Okay. The electrical signal may be a voice signal, or it may be image signal, or it may be a video signal. Okay. So video compresses both voice and the image signal. So for example, you can take a phone. While speaking through the mobile phone, the voice is converting to the electrical form of signal. Okay. So for this, in this transmitter section, we are connecting the transducer. So what is the purpose of the transducer? We know that transducer convert one form of energy to the another form. Correct? Okay. So same thing only. Here also the electrical signal is converting to the optical signal. Okay. So this electrical signal is converting to the optical signal. So this input signal may be a voice signal, or it may be a image signal, or it may be a video signal. So now this input signal is given to the driver circuit. What is the purpose of this driver circuit? So next block is the light source. This light source may be a LED or laser. Okay. In optical, the input light source is the LED and laser. Okay. So now, while we are using laser, means it emit more amount of heat. Okay. So in order to suppress this heat, we are using the driver circuit. If you, for example, in the computer, there are more fans are used. Correct? Okay. So why? In order to reduce the heat, to cool the hardware system. Similarly, here also, this driver circuit is used for reducing the heat in the laser circuit. Okay. If you are using the laser, then the heat will be reduced by this driver circuit. So this light source may be LED or laser. So these are the two important optical sources we will study later. Okay. LED and laser. It is the important light sources, optical lasers, light sources. And next is the, see, that is the fiber fly lead. What do you mean by fiber fly lead? It is the short length of the fiber. A small length of fiber is known as the fiber fly lead. So next is the connector and splicer. Okay. So what do you mean by connector and what do you mean by splicer? Connector means it is used to connect one component to the other component. Okay. That is, in order to connect from one device to another device, we are using the connector. For example, if you can take the probe. What is the purpose of probe? We are connecting a CRO with another device. Okay. Similarly, here also, the connector is also used to connecting the one component to other component. Okay. So, the important thing is connector is a temporary connector. Okay. Only temporarily we can connect this connector. And we can, whenever we need it, we can remove it. And next is the splicing. Splicing is the permanent connection. You can permanently connect it in the optical system. Okay. For example, while if you want to connect any wire, permanent means what will we do? We will soldering. Correct? Okay. Similarly, here also, in order to connect any two medium, that is the two optical fiber cable, here we are using the optical splicer. It is a permanent connection. We cannot remove this, but connector is a temporary connector. We can remove this. Okay. And next is the optical coupler or beam splitter. What is the purpose of optical coupler? That is, through this optical coupler, you can give more number of inputs can be added through this optical coupler. Splitter is used to connect to various other equipment. Okay, in order to connect more number of equipments, you can use this optical coupler or beam splitter. In order to add more number of inputs, we can use this optical coupler. In telephone cable itself, you can see this optical coupler. Okay, and the next device is the regenerator or repeater. It is the important main thing in this elements of the optical fiber transmission link. What is the purpose of this regenerator or repeater means? So it covered some distance and it convert the optical signal to electrical signal, again electrical signal to optical signal. Okay, so this regenerator, for example, if you take the street light, it covers only a small distance, and again another distance we are using another street light. Same thing, for some distance, in order to convert the optical signal to electrical signal, we are connecting the regenerator, and again for long distances, more number of repeaters or regenerators are used. Okay, and the next thing is the optical amplifier. So there are three types of amplifier. One is pre-amplifier and inline amplifier and the post-amplifier. So pre-amplifier will be used nearby the transmitter section, and post-amplifier is used nearby the receiver section, and the optical, this amplifier is the inline amplifier. In between the transmitter and receiver, we are using the inline amplifier. Okay, so this is the optical amplifier, that is the inline amplifier. And next is the last part is the receiver section. In this receiver section, we are using the photodetector, amplifier and signal restorer. So what is the use of this photodetector? So this photodetector acts as the normal PN junction diode, but it acts as the reverse bias condition. Okay, you know, in reverse bias condition, the depletion layer will be very high. That is, it acts as the magnet. So what happens in this photodetector means it observes the incoming light, and inside this the light there is a quantum. Now the quantum will break down into two parts. One is the photon and another one is the phonon. So photon acts as the light and phonon acts as the vibration. Okay, so in this photon, it acts as the light. So now a new current is generated. Using this photodetector, new current is generated. So these are the optical detector. The two main optical detectors are photodetector and avalanche detector. So it will be discussed in the fourth unit. Okay. So in the receiver section, we are connecting the photodetector, amplifier and signal restorer. So the function of the photodetector is it converts the optical signal to the electrical signal. That is, a new current is generated. So nearby photodetector, the amplifier, that is the receiver side post amplifier is connected. I said you there is amplifier is of the three types. So it is the post amplifier. So in the receiver section, it amplifies the signal. And next is the signal restorer. So what is the function of the signal restorer? That is, the original input signal will be recovered without any change. For example, in the input side, if you are sending the voice signal has the high pitch, low pitch, correct? Okay. So without any variation, the output side also the same voice signal will be received. So for this purpose, we are connecting the signal restorer. Okay. So this is the overall view about the block diagram. So here the step by step explanation is here. What is the purpose of drive circuit? What is the purpose of repeater? What is the purpose of receiver? Okay, so students, so go through this block diagram. So it is an important 13-mark question. So if you have any doubt, comment me in the Google Classroom. So once we can recall this. So today we have studied about the optical communication. You know, optics means the light. Communication through the light is the optical communication. And next we have see some advantages, and then we have see the elements of the optical fiber transmission system. That is, the three main blocks are transmitter section, medium is the optical fiber cable, and the regenerator, and then the receiver. Okay. So the transmitter section has two parts, driver circuit and the light source, and in between we are connecting the optical coupler, beam splitter, connector, splicing, and then regenerator. And next in the receiver section we are connecting the photodetector and the amplifier and then signal restorer. Small classes itself you studied about reflection. When the light strikes the boundary of two media, a part of the light is turned back. Shortly, the reflection means bouncing of light. When you throw a ball, it gets bounces. Similarly, the light also, when it travels from one media to other media, it gets bounces back to the same media. So if you take sun, candle, bulb, so they have the capability of generating their own light. That is, they emit light. So they are known as the luminous light, correct? So the bulb has the property of emitting the light. That is, they can generate the light by their own. So if you see chair, bricks, etc., they cannot generate the light. So when light hit on these subjects, the light gets reflected. Okay. So next is the laws of reflection. First one is the angle of incidence is always equal to the angle of reflection. So see the diagram. The incident ray, when the light is incident on the surface, it gets reflected. So now draw one perpendicular line between the incident ray and the reflected ray. So now what happened? The incident ray is equal to the reflected ray. What do you mean by incident ray? The incident ray is a ray of light that strikes a surface. So the angle between the incident ray and the perpendicular or normal is known as the angle of incidence. Okay. So the ray that thrown back from the non-absorbing surface is known as the reflected ray. So now what is angle of reflection? The angle between the normal and the reflected ray is known as the angle of reflection. So next is the second law. So what is point of incidence? The point on the surface where incident ray strikes the surface is called the point of incidence. Okay. So here the second law states that the incident ray, the normal at the point of incidence and reflected ray all lies in the same plane. See the diagram? The incident ray, normal at the point of incidence and reflected ray lies in the same plane. Students, we have studied about the reflection and the laws of reflection in this video. Okay. So next we are going to study about what is refraction. What is reflection means? When the light is traveled from one medium to other medium, part of the light get reflected and other part get refracted. Correct? When it travels along the opaque subject, the light get reflected, and when it travels along the transparent subject, it get refracted. So what is opaque subject? You can take example mirror. Transparent subject, you can take example as the prism. That is the transparent object. Okay. When it travels along the transparent object, the light get refracted. So shortly, what is refraction of light? Bending of light when it travels from one medium to another medium. The light gets bends. So reflection means bouncing of light and refraction means bending of light. For example, take a glass of water and dip a pencil inside the water. What happened? The pencil seems to be bent because due to the refraction. Correct? When the light moves to the rarer medium, it moves away from the normal. So what do you mean by normal? It is a perpendicular line. Correct? Okay. When it is moved to the denser medium, it moves towards the normal line. Okay. So in the refraction, when the light is moving to the rarer medium, it moves away from the normal. The denser medium means it moves towards the normal. So students think, why it is changing the direction of the light? Because the change in the direction of the light is caused by the changing its speed. Okay. So when the speed of the light changes, then the direction of the light is also changes. See this diagram. When the light moves from air to glass, the direction of the light is changes. Again, when it moves from the glass to air, the direction changes. So refraction means it changes its direction when it travels from one medium to another medium. So it can be explained by the refractive index. It is based upon the refractive index. So what is refractive index? The amount of refraction. Okay. So how we can calculate the index of refraction means it is the ratio of the speed of light in air to the ratio of the speed of light in substance. Okay. Speed means the velocity. So you know the speed of the light is 3 into 10 power 8 meter per second. And the speed of the light in any other given material. Here the given chart is the refractive index of various medium. That is the refractive index of the air is 1 and the refractive index of water is 1.33. So when the light travels from air to water, bending of light occurs. Okay, next is the law of refraction. Likewise in reflection, here also there are two laws. First law is same as that of the second law of reflection. That is the incident ray, refracted ray and the normal lies in the same plane. their incident ray, reflected ray and the normal lies in the same plane. Okay. And second law of refraction is the Snell's law. So what does Snell's law means? Snell's law states that how the light ray reacts when it meets the interface of the two medium. Okay, so these two medium have different index of refraction. It is expressed mathematically n1 sin phi 1 equal to n2 sin phi 2. What is phi 1? Phi 1 is the angle of incidence. So what is the angle of incidence? The angle between the incident ray and the normal. And phi 2 is the angle of refraction. And what is angle of refraction? The angle between the refracted ray and the normal. Okay, so Snell's law expressed mathematically as n1 by n2 equal to sin phi 2 by sin phi 1. So what is n1 and n2? The refractive indices of the two medium. So here listen, one important condition, n1 should be greater than n2. What is n1? The refractive index of the first medium. n2 is the refractive index of the second medium. So this will be understand while you studied in total internal reflection. Okay? Student, total internal reflection. So the basic principle of optical fiber is the total internal reflection. So very important 2-mark question. So with this principle only, inside the optical fiber the light is transmitting. So it is very important. Students, we can recall what is reflection and refraction. So you know, reflection means when a light emits from one medium and it gets strikes in another medium and it gets reflected. Correct? And what is refraction? The bending of light occurs when it travels from one medium to other medium. Okay, based on the refractive index. So now we can see the principle of total internal reflection. Okay. So first see the diagram. Here let us consider a ray of light passes from glass to air. That is from the denser medium glass to rarer medium air. Okay. Then what happens when a ray of light, when it strikes on the surface, the major part get refracted and a small portion get reflection. Okay. Reflected. We have studied earlier. So same thing here also happening when a light is traveled from the denser medium to rarer medium. Major part of the light get refracted and a small portion get reflected. Okay. And the next step in total internal reflection is we want to slightly increase the angle of incidence. When angle of incidence increases, what happens? The angle of refraction also increases. So now the angle of incidence increases, the angle of refraction is also increases. So you can see the second diagram. The angle of incidence increases, the angle of refraction ray, that is that yellow line is also increases. Okay. Now in the third step, at a certain angle of incidence, that is the critical angle. Okay, what do you mean by critical angle? Means when the refracted ray travel along the surface of the two medium. Okay, so now that yellow line is traveling along the surface of the two medium, that is the refracted ray is traveling along the surface of the two medium. Now what happened? The angle of refraction is equal to 90 degree. Okay, so when the angle of refraction is 90 degree, that angle is known as the critical angle. Okay, so when angle of refraction is 90 degree, the angle is known as the critical angle. Next step, further we are increasing the angle of incidence. What happened? The light bounces back to the same medium. According to the law of reflection, we have studied two laws. So it obeys one of the law, that is angle of incidence is equal to angle of reflection. Okay, so this is the basic principle of total internal reflection. And now there are two conditions in which the total internal reflection obeys. The two conditions are the ray of light must travel from the denser medium to rarer medium. And the second condition to be satisfied is the angle of incidence must be greater than the critical angle. Okay. And now see this diagram. Inside the optical fiber cable, the light is traveling in a zigzag manner. That it is according to the total internal reflection. The last step of total internal reflection, we have studied that the angle of incidence, when it is greater than the critical angle, it gets reflected back. So I hope you understand the principle of total internal reflection. So this is the principle in which the light travel inside the optical. Now we can see the derivation of the critical angle. So listen students, the next topic is the critical angle. So what is critical angle? It is the angle of incidence that causes the refracted light to travel along the interface between two media. So previously we have studied the total internal reflection. In total internal reflection itself we have seen the critical angle, that is when the light is incident on the interface, that is this is the incident ray, correct? It is the incident ray and it is the normal line. When we increase the incident ray at one incident, what happened? The refracted ray lies in the surface of the two media. Okay, it lies in the interface between two media, or it lies along the surface of the two media. That is, the refracted ray lies on the interface between two media. So it is the refracted ray. So now this angle is 90 degree. That is, the critical angle value is equal to 90 degree. According to Snell's law, what is Snell's law? Mathematically we can express Snell's law as n1 sin phi 1 equal to n2 sin phi 2. So what is phi 1 and phi 2? Phi 1 and phi 2 are the angle of the incidence and angle of the refraction. Okay, so now sin phi 1 is equal to n2 by n1 into sin phi 2. Okay, so now we know the critical angle is equal to 90 degree. So now the angle, that is phi 2, that is the angle of refraction, is equal to critical angle. So phi 2 is the angle of the refraction and phi 1 is the angle of the incidence. So when phi 2 is equal to 90 degree, what happens? Phi 1 becomes the critical angle, that is phi 1 is equal to theta c. So now substitute these two values in this equation. So it becomes sin theta c is equal to n2 by n1 sin 90 degree. What is the value of sin 90 degree? Sin 90 degree is equal to 1. Okay. So now theta c is equal to sin inverse n2 by n1. So the critical angle can be represented as theta c is equal to sin inverse n2 by n1. Students, the next topic is acceptance angle and numerical aperture. So what do you mean by acceptance angle? Means it is the maximum angle to the fiber axis at which the light ray may enter the fiber axis in order to propagate it. That is the maximum angle to the fiber axis is the acceptance angle. Okay. So at this acceptance angle only the light will be propagated. If it is away from this maximum angle, means the light does not propagate. The next is the numerical aperture. What is numerical aperture? Means it is used to describe the light gathering or light collecting capability of the optical fiber. Okay, total amount of light collected. So while seeing the derivation of numerical aperture and acceptance angle, you will understand. Numerical aperture mathematically expressed as Na is equal to sin theta. Keep it in mind, it will be useful in derivation. So students, the next topic is the acceptance angle. So what do you mean by acceptance angle? It is the maximum angle to the fiber axis at which the light may enter the fiber axis in order to get propagated. So in order to get the light propagated, the light ray may enter the fiber axis. Okay, so this is the acceptance angle. So now we are going to study about the derivation of the acceptance angle. So first take a fiber. So this is the fiber. In the next topic we are going to study about the structure of the fiber. Then you will understand clearly. So the center portion in the fiber, it is known as the core, and surrounding the core there is a cladding. Okay, so it is mentioned here, core with a refractive index n1 and cladding with refractive index n2. Okay, so it is the center axis. So now when the light ray incident on the center axis, okay, what happened? So it get refracted. When the light ray incident, the light get refracted. Okay, so when light get refracted, so internal reflection will occur, correct? Okay, so now the total internal reflection is occur here. So in this manner the light will travel along the optical fiber. Okay, the light travels along the optical fiber. So this is the acceptance cone in which the light rays enter the fiber. Okay, so when the angle phi increases, the light rays enters inside the, when this angle phi increases, the light ray enters inside the core. When this phi angle that phi decreases, what happens? The light falls outside the core. So now if you are decreasing the angle, what happens? So you are decreasing the angle, definitely the signal will be lost because you are decreasing this angle. When you decrease this angle, what happens? The signal will be lost. Okay, the signal will be lost and it radiated outside the fiber. So now join this. So this is theta 1 and this is the signal lost. This phi and this is theta 2. Okay, so now next you can go for the derivation. So according to Snell's law, what is Snell's law? You know, n1 sin phi 1 is equal to n2 sin phi 2. Okay, so here this medium is the air and the refractive index of the air is n0. So here you can write according to Snell's law, what is the value? n0 sin theta 1. So here the refractive index is n0 and the angle is theta 1. Okay, so n0 sin theta 1 is equal to, what is the value? n1 sin theta 2. Okay, n0 sin theta 1 is equal to n1 sin theta 2. So the refractive index of the air, so in air the angle is theta 1. So this is the acceptance angle. Okay, and in core the refractive index is n1 and the angle is theta 2. Okay, that is the angle of refraction. So according to Snell's law, n0 sin theta 1 is equal to n1 sin theta 2. That is, n0 is the refractive index of the air and in air there is acceptance angle that is theta 1 and the refractive index of the core is n1 and inside the core there is a refractor ray that is theta 2. So according to Snell's law, we write this equation. Okay, n0 sin theta 1 is equal to n1 sin theta 2. So now from the figure, see this portion. That is, it is in Z size, correct? Okay, so it is in the form of the Z. That is, here the angle theta 2 and here the angle phi. So now this angle and these two angles will be equal. So this is also theta 2 and this is also theta 2. Okay, so now from figure you can write theta 2. This is theta. Okay, theta 2. Theta 2 is equal to, what is the value? Pi by 2, that is 90 degree minus pi. This angle is equal to, so this is the critical angle 90 degree minus this pi value. You know, critical angle value is 90 degree. So theta 2 is equal to 90 minus pi. So theta 2 is equal to 90 minus pi. So now substitute this. Take this is equation number 1 and this is equation number 2. So now substitute equation 2 in equation 1. So what happened? n0 sin theta 1 is equal to n1 sin, what is the value of theta 2? Pi by 2 minus phi. That is 90 minus pi. What is sin 90 minus pi? Cos pi. Okay, n0 sin theta 1 is equal to, what is the value? n1 cos phi. Okay, so according to mathematical trigonometric representation, sin squared phi plus cos squared phi is equal to 1. So what is the value of cos squared phi? Is equal to 1 minus sin squared phi. So the value of cos phi is equal to root of 1 minus sin squared phi. Okay, so take this is equation number 3 and this is equation number 4. Okay, and now substitute these values. So it become n0 sin theta 1 is equal to n1 in the place of cos phi, that is substitute equation 4 in equation 3. Okay, so n1, what is the value? Cos phi. So the value of cos phi is root of 1 minus sin squared phi. Okay, root of 1 minus sin squared phi. So for critical angle, already we have studied this derivation, correct? What is the critical angle derivation? The critical angle derivation is sin of critical angle equal to N2 by N1, correct? N2 by N1. So now take this is equation number 5 and this is equation number 6. So now substitute this value in this equation. So take this as the critical angle 5C. So now substitute equation 6 in equation 5. Okay, in equation 5. So now what is the value? N0 sine theta 1 is equal to N1 root of 1 minus N2 squared by N1 squared. Okay, N2 squared by N1 squared, that is root of 1 minus N2 by N1 the whole square. So can you understand? So next, N0 sine theta 1 is equal to root of, so now when you take the LCM, what happens? N1 squared minus N2 squared by N1 squared. So now when this N1 squared come out of the equation, it become N1. Root of N1 squared minus N2 squared. So these two values get cancelled. So N0 sine theta 1 is equal to root of N1 squared minus N2 squared. So this equation can be represented as it is a numerical aperture equation. So it can be written as numerical aperture equation. So for air, what is the refractive index there? For air, the refractive index N0 equal to 1. So now it becomes sine theta 1 is equal to, that is the numerical aperture equal to root of N1 squared minus N2 squared. Okay, root of N1 squared minus N2 squared. So this is for numerical aperture. Then for acceptance angle, and write for acceptance angle theta 1 is equal to sine inverse of numerical aperture, because theta 1 is the acceptance angle. So now the acceptance angle is equal to sine inverse of numerical aperture. So what is the value of numerical aperture? Numerical aperture value is N1 squared minus N2 squared. Okay. So what is the definition of numerical aperture? It is used to describe the light gathering or light collecting ability. Okay. So the how much of the light is gathering or how much the fiber collect the light. So that is the numerical aperture. So now we can modify the numerical aperture equation. That is, we have derived that numerical aperture in terms of the acceptance angle is numerical aperture equal to sine theta a. What is the value? Root of N1 squared minus N2 squared. So now you can write a squared minus b squared is a plus b into a minus b. So here the index difference value is del n is equal to N1 minus N2. So now it can be written as N1 plus N2 into del n. Okay. So when N1 is approximately equal to N2, what happened? This N1 plus N1. Okay. So it becomes 2N1 into del n. Okay. So it is one formula of numerical aperture. Numerical aperture, it is one form of the formula for the numerical aperture. So another one formula is numerical aperture, we know in terms of the acceptance angle sine theta a, that is root of N1 squared minus N2 squared. So now you can separate this with a plus b into a minus b formula. So what is the relative refractive index formula is del is equal to N1 minus N2 by N1. Okay, N1 minus N2 by N1. So from this cross multiply. So del N1 is equal to N1 minus N2. So now substitute this value in this equation. In the place of N1 minus N2, you can substitute del N1. Okay, so N1 plus N2 into del N1. So here also when N1 is approximately equal to N2, what happened? It become 2N1 del N1. Okay, so it can be rewrite as numerical aperture equal to sine theta a is equal to root of 2N1 squared del. Okay, so the formula for numerical aperture in terms of acceptance angle is sine theta a, and in terms of relative refractive index is N1 into root of 2 del, and in terms of the index difference is root of 2n1 del n. Okay, root of 2n1 del n. So these are the different formulas for numerical aperture which may be used in the problems. Okay, so you must remember these formulas in terms of index difference, in terms of acceptance angle, and in terms of the, sorry, this is in terms of the relative refractive index, it is in terms of the index difference del n. Okay, thank you.